Miss, I learned pH, but how do people test pH?
Good question. Normally we use a pH meter, but you can also test pH at home. My friends and I will show you how to test pH using simple material that you can find at home.
Hi everyone, welcome to our biochemistry video presentation. Our topic today is natural pigments as pH indicators.
Hi, I'm Lily.
Hi, I'm Julia. Hi, I'm Serena.
Hello, I'm Yongshen.
The objective of this experiment is to investigate how pigments from red cabbage and turmeric change color under different pH levels, and to show how they can act as natural pH indicators for food application.
Now let's weigh our material. We use 1/4 of red cabbage, 1 teaspoon of turmeric powder, hot water, dropper, pestle and mortar, a few pickles, filter paper, A4 paper,
Kitchen towel, conical flask and filter funnel.
For our test liquid, we prepare 5 acids: lemon juice, vinegar, lime, yogurt, and milk. 4 bases: cleaner, baking soda, toothpaste, eno.
Let's start by making our natural indicators. Chop some red cabbage. Mix it with hot water until the liquid turns purple. Filter the cabbage juice. Stir turmeric powder into hot water to get a bright yellow solution. Be careful, turmeric can stand, so handle it with care. We use hot water to get a stronger color quickly. Hot water helps pull the pigments out faster. If you only have cold water, it will still work, but the colors may be lighter and take longer to appear. Next, cut the papers into strips. You can use kitchen towel, A4 paper or filter paper. Use whatever you have. Dip a strip into cabbage or turmeric for 2 to 3 seconds. Then lay it flat to dry. We use a drying oven to accelerate our process. Set up your test liquids in small cups, bowls, or anything you have in handy. In our case, we are using beakers since we are in lab. Make sure to label them. When handling strong liquids like floor cleaner, we wear gloves. This isn't a magic potion, so don't drink it. Now we are ready to test the strips. Place the dry strips on the table. Add a single drop of your liquid in the center. Watch the color change right before your eyes.
Now we have tested our homemade pH strip. Let us look closer at what happened. For the red cabbage strip, acidic liquids like lemon juice, lime, vinegar, and yogurt turns the purple strip from purple to pink. As we can see from our result, lime and lemon juice is much more acidic because it appears darker pink. This is our control distilled water. It remains no color change, which the result is reliable. It shows the original color and is used for comparison. For the turmeric strip, acidic and neutral liquid stays yellow, showing no change. This is our base sample. For the red cabbage strip, basic liquid like baking soda, toothpaste, and floor cleanser turn purple to blue. For the turmeric strips, baking soda, floor cleanser appears brownish color, and toothpaste show little changes. From the other hand, we cannot observe any changes on soapy water. Let us go to the pH meter to have a check. This is a sample of baking soda. As we can see, the pH is over 7, is at 8.53. This indicates that baking soda is a base and matches the color changes observed. This is our soapy water sample. As we can see from the pH meter, data is 6.7 and is quite neutral, which is not alkaline. That's why it remains unchanged at the paper strip.
Now I'll be talking about the theory behind our experiment.
In this experiment, we are exploring how natural pigments like anthocyanin from red cabbage and curcumin from turmeric act as pH indicators. Let's start with the science behind it. Both pigments can change color when they come in contact with acid or base because their molecular structure react to hydrogen ion in the solutions. For red cabbage, the pigment anthocyanin is responsible for the color. When it is in acidic solutions, it turns pink or red. When it is neutral, it stays purple, and in the basic solutions, it changes to green and blue. This happens because the anthocyanin molecule can change shape depending on the pH level. Next, for the turmeric, the pigment curcumin stays yellow in acidic or neutral solutions, but turns reddish brown in basic solutions. This is because, in basic conditions, curcumin lost a hydrogen atom and forms a new chemical structure that reflects a different color. Now, how does this relate to real life? These pigments aren't just for experiment, they're just for in everyday food. For example, red cabbage, blueberry, and purple sweet potato get their color from anthocyanins. Turmeric, which we cook in curry, is colored by curcumin. Chefs usually use this knowledge too. If you cook red cabbage with vinegar, it stays bright red, but if you add baking soda, it turns bluish. So overall, this experiment shows how biochemistry and food science connect, using safe, natural pigments to visually detect pH level just like synthetic indicators, but in a more eco-friendly and fun way.